Hi, I'm James McGuire, Editor-in-Chief of eWeek. And on today's webinar, we're giving expert advice on the knowledge that you need and the strategies that you need to confidently use large language models in your applications. We know that building AI-powered applications with large language models offers enormous potential, but navigating this new space can offer all sorts of challenges, including security, legal, and compliance issues. So today, we'll talk about how to harness the power of AI while mitigating the risks. To discuss that, I'm joined by three industry experts. With me today is Chris Lindsay, Application Security Evangelist with Men.io. Chris, good to have you on the panel today.
Thank you, James. Nice to be here.
Also with me is Maciek Mensfeld, Principal Product Architect at Men.io. Maciek, good to have you with us.
Thank you for having me. I'm happy to be here.
And rounding out our panel is Ron Schemmer, Senior Software Developer at Men.io. Ron, welcome aboard.
Thank you, James. Nice to be here.
So before we get started, just a couple of housekeeping notes. We do have a question and answer box. We very much welcome your questions. We'll try to get to them at the end. If not, if we run out of time, we can still reach out to you and give you an answer. And you can you can put in your questions at any point. You don't need to wait until the end. There's also a chat box if you want to offer some comments at any point. So please feel free. All right, I know the three of you have a presentation. Please go ahead and get started whenever you're ready.
Thank you, James. So let me kick us off. So starting with the agenda, today we're going to talk about LLM selection and integration along with compliance. We're going to talk about mitigating your risks. We're going to talk about strategies for AI applications, and then we're going to wrap up with our Q&A. So let's kick off with our introduction. LLMs are not just changing the game, they're creating entirely new playing fields. Maciek, what does this mean?
Yeah, that's a really good sentence to start this discussion. I think it's LLMs are one of those breakthroughs that create new opportunities that we did not see, or that we think possibilities to achieve things that we weren't able to do, instead of like slightly shifting where we are. And for me, that makes a lot of new things really interesting, and it allows me to do things that I never thought I could do just because of scale or certain other limitations. But if you look at where we are with large language models, it's good to look into this. I think I don't want to say previous revolution, but like 2010, where the first AI hype happened, everything that would be labeled AI would get VC funding and things like that. But it was so much different than where we are now. So first of all, AI development was characterized by specialized models tailored for specific tasks. This required a deep expertise in machine learning, algorithms. You had to have a lot of data. You had to have a lot of knowledge, teams of specialists. All of this had created a high entry barrier to using AI, both for big organizations, right? But also for small startups, solo developers, people that had ideas but did not have resources. And LLMs changed that. I myself was like really skeptical about large language models initially. I only started to see a lot of value in them when I started using them a lot, when I started to work with them. And the more you work with them, the more use cases you get. They are versatile, they're pre-trained, they're capable of understanding and generating human text, images, and videos, right? Which allows you to do so much more than by yourself, right? So they definitely lowered the technical barrier for using AI. They do offer a cohesive approach, and what is the best thing for me, they allow for quick prototyping. You have an idea, you can validate it in a certain scale really fast. You can test your assumptions, your concepts, and well, if they're good, hopefully you're gonna end up with another unicorn.
Yeah. So one thing that I think really made things speed up in that area was opening or open sourcing these models, and not only the models themselves, but also the data sets and training methods and deployment, or the way it's called in that area is inference methods. And we can see a lot of community contributions that really speed things up. And I think that at least for me, from what I've seen, one really significant financial barrier that was very really lowered was really lowered by some community contributions was giving us the capability to actually run these really large language models on our local machine without any special GPUs, and even in terms of user-friendly, it's really something that anyone with basic um, technological capabilities can do today, and it really brings us a lot of opportunities. And like you said, Maciek, we have the more you use it, the more use cases you can see. It will be very useful and make us go even further. And on top of that, opening those LLMs can give us some increased transparency in terms of being able to see the data and the algorithms being used for the training and the inference. And we'll talk about some of the architectures later. But we need to keep in mind that if we're going to start this LLM journey and start using such models, we need to consider also the, let's say, potential pitfalls of using something that is open, because pretty much like in other software components that we can see, once it's open, we get all the benefits that I mentioned earlier, but we can also come across some challenges in understanding and making sure that we are compliant with the licensing of these models and data sets, and we need to make sure that we keep up with the qualities and the standards that we're working today with any other software. And that's make it a bit harder if that's something you're using some component that keeps getting contributions from random people. So it's not, Maciek, you know what I'm talking about. It's hard
I'm
to
just
yeah.
I'm just laughing because it's it's open source space, right? And I feel that with large language models, with AI, we're in a stage where we were a few years ago with open source software. There are not a lot of good practices related to security, to management, to compliance, both like legal and engineering wise. And I'm just laughing because I think about how fast this space is growing and how the governments and many regulational bodies are trying to keep up with that, and at the same time how many new interesting risks and attacks are emerging. So as you said, that's definitely something amazing, the open source space of LLM models, like alongside of the proprietary models, right? But open source does not always mean free or not risky, and yeah, that's what we're gonna talk about soon.
Yeah. So
Okay. So using AI is like riding a bike. Anyone can ride it. However, many people crash at the beginning. Maciek, you got a story on this, don't you?
Yeah, I have few. I'm gonna tell you
just,
one.
just a few?
Yeah, a short one. Yeah. So I don't know like exactly what our audience is, but I can imagine that there are here some people that did not deploy AI-based systems to production yet, right? I did. And there's one funny story. So as with any project of that nature, LLMs can be expensive, right? They can be either slow or expensive, and especially if you want to run it in the scale of hundreds of thousands of queries, prompts. And I did that. I ran my numbers. I got some estimates. It was supposed to cost me $200 to run the prompts. I built a POC. I even measured the cost based on the POC. I was quite confident. I put it in production. 70,000 prompts later, I did get the responses that I wanted. The issue was I didn't get the bill that I wanted. I got a bill that was 8 times bigger. And yeah, that was one of my unpleasant rides, if I can say it that way. But this is how we learn, right? We try things out, we break things, we take some conclusions out of it, and we jump on the bike again and keep riding.
Absolutely. So what you're saying, Maciek, is watch the bill. Don't wait for the bill to show up. Make sure that you're staying on top of things, just because you don't know how many resources you're really tying into until you get the bill, and then it's there. So,
well, listen, one could say I did something wrong. I don't think so. I did post-mortem on my spendings, and what I noticed is that 80% of the bill actually came out of 20% of misbehaving results, right? This is something you can expect from large language models, and yeah, this is what got me. So yeah, watch the bill is definitely one of the things. It's not a security advice, but based on my experience with the commercial large language models or open source models that run in the cloud, you definitely need to keep an eye on that.
Absolutely. All right, so let's talk about LLM selection and integration. So selecting an AI is easy. Just ask it, and it will tell you. I think that's kind of a joke, but you'll get some interesting insights. Because if you ask it, it will tell you something, good or bad, and we'll talk more about that coming up. Let's talk about LLM's integration approaches. Ron.
So when we are about to choose an LLM, I guess we already have some task in mind that we want to implement using an LLM. Usually it's something that someone is already doing manually in some way. And before we're going to talk about how we choose a specific LLM, or actually we can say that this is a general approach for any ML model, but specifically we want to focus on LLMs. So when we want to choose the model, we want to keep in mind that we have some different approaches, not very different, quite similar, but choosing one of these approaches can make some difference in which model we're using and the performance that we get. So I'll give a quick overview of the integration approaches that one can use today. Of course, there may be other approaches in the future, but these are the most common and most known approaches that we have today. So let's kick off with the first one, and it's taking the model as is without changing the model itself. So that means that we have the benefits of not maintaining any changes to the model, and I'll explain later in the other approaches what it means to maintain the changes. And we need to give it some context in order to get relevant results for our task, because these large language models, they are trained on very generic data, and if we want them to perform a specific task, we need to guide them. So usually we can use a system prompt to to give some static context to the LLM, and this would usually be some role or some basic instructions like which language to answer. And I think some of us even saw prompts that are explain it to me like M5 and so on. And this could give us better results than just shooting questions or asking for data from it. Now, the second approach is fine-tuning a model, and we can use this approach to make the model a bit more custom for our needs. And this is done by using usually small data sets. Could be hundreds or thousands of examples. It's preferred to be examples of this task, and it should be both do's and don'ts examples. But here comes the less enjoyable part, and we need to maintain it. I mean, usually when we fine-tune a model, we are using some data set, and this data set may change or grow, and we may need to feed it with more data. So I think that one classic example that we're all familiar with is some knowledge base for, a chatbot for our company knowledge base. And if we fine-tune a model with our knowledge base, could be some internal documents, we need to keep fine-tuning the model with more data that is generated a long time. And in order to avoid this, we have the retrieval augmented generation approach that is using instead of fine-tuning the model, we are still using the model without fine-tuning it. Actually, we can fine-tune it for the specific task, but I think that it's better to keep it simple for start and not fine-tune it. And we give the LLM our context when we get the input for it. So we have the retriever that can get database or code from Git or documents, and this is how the flow will look like. So let's say that we have a question, and assuming this large language model was not trained on Wikipedia, or that Wikipedia was not up to date when it was trained, so the retriever can give us additional information together with the query, and then we can get a response that is more up to date and more relevant for our use case.
No, that's great information. So choosing an AI model is like eating at the buffet. There's lots of choices, some good, some bad, and we're going to get into that now. So take a look at Hugging Face. Hugging Face has over 550,000 models. It keeps growing on a day-to-day basis. Finding which model you want is the hardest part because you have so many models doing so many different things. You know, it's not just, hey, we have one common model that does everything. I mean, there's specialization. You have chatbots, you have lookups, you have code generation, code vulnerability. I mean, just on and on and on and on and on. And officially, there's 550,000 models, but 400,000 just a couple of months ago. And so, you know, things to look for. Is the model popular? You know, look at the downloads and look at the number of uploads and likes, because if, you know, the more popular the model is, the better the model probably is. If you have a model that's out there and there's a few likes and a few downloads and that's it, most likely it could be a good model, but not too many people have tried it. Or it could just be a model where, you know, it just falls flat. There's just not too much to it. And so, you know, look at the downloads, the upvotes to, you know, pick on the ones that are a little bit better. Look at the trustworthiness. That's important, because if a model is not trustworthy, would you really want to bring that into your environment? That's kind of asking for, you know, for problems. And check out the author, right? Sometimes, you know, they don't have a verified account. You should really stay away from those if you can. unless you know the model and you know the person directly, they just haven't created their verified account. But having that account verification gives you that added bonus on trust. Is this a model that I can trust? Is this a model that I can actually, I feel comfortable using? Because if you don't feel comfortable using the model, because the model could be poisoned or have malicious intent in it, that's important to know. And so making sure that you're looking at a high download with a high upvote, looking at the trustworthiness and looking at the author are absolutely key for success. So, things to look for is look for spam reports, right? So if somebody has put a model out there and they're, people can go out and mark, hey, there's spam in this thing or something that's not right. So, look for that kind of things when you're looking for your models. Look at the performance issues and weaknesses. This is important. I mean, Maciek was just talking about the cost overrun. You figure out how much this is going to run you and what your budgets are. But if you're not planning for potential performance issues, that might be something that, if you haven't started or you're looking down, I would definitely put some kind of wiggle room in your budget for that, just in the event that, there's a performance issue. It takes more effort, more computing power than you had planned. It will cost you a little bit more money, right? And something else to do is look at inactive models. It's like dependencies in open source. People create models. They put them out there just like dependencies. And at some point, they version them. They have newer versions, or sometimes they just kind of get left alone. And so you don't want to go spend a whole bunch of development effort putting in a new model that's been abandoned by the developer or by the uploader. So make sure that you're looking at models that have a lot of activity, that's current activity, because if you're not, you might find yourself implementing a model that's stale and old. And so that's something to pay attention for, right? So things to look for. Maciek, what should we be looking for?
Depends how you look at things, right? So what I like to do is to always eliminate things fast before any heavy time investment. So I start with the license and copyrights assessment, right? The model that I want to use actually, does it contain a license that allows me to do certain things, right? Obviously, putting aside the question, am I legally allowed to do certain things, right? Biometrics and other things that may or may not be regulated in your country. That's always the first thing. The second thing is, as I said, license, the most important thing, right? Does the license allow me to use the model for commercial work, for research? Does it allow me to fine-tune the model without exposing the derived work, right? Can I use this model as a foundation model for my model? And those are the primary legal questions. And after that, I like to review the model cards on Hugging Face. There's one thing worth keeping in mind, though. This model card can be edited. It's not something written in stone, so it doesn't have to be true. But it usually provides some relevant information, right? Like about things you've mentioned, performance, training data set information. This may be also important from the legal perspective. Was this model built and trained on legally obtained data, right? If it's a derived model, what is its foundation model? Can I use that, right? What was the fine-tuning process? What are the requirements to run it? There are few primary formats for running LLMs. Am I even able to run it, right? If it was quantized, what is the accuracy of this quantized version of this model? And in general, how does it behave, right? So I try to automatically remove things that are like legally prohibiting me from using that, and then I go into the performance and the quality assessment. And to do the initial quality assessment, I just use a available playground. Which one you use really depends on where you are, what platform are you using. There's the Hugging Face playground. I know AWS provides one, and there are a couple more. As you guys mentioned, you can even run majority of the open source models. You can just run on your machine as long as you have a decent setup. It's not going to be the fastest. It's not going to generate, I don't know, 80 tokens per second or something like that. But it should be enough for you to run it and in 5 minutes get some results. So you get this initial feeling about models you're interested in. So yeah, the open sourceness of things definitely makes things easier.
Yeah.
Yeah, and one quite important thing to look at when you're checking out a model is look at its architecture. So it's something a bit more technical that you need to do some deep diving to understand better. But at the high level, we can see that different architectures can give better results for some tasks. So, for example, we know that on the GPT models, they are very good at text generation, while BERT models are better at understanding text rather than generating text. And we can do this. We can check out which architecture of the model is built upon, and usually it's like something that is an additional label in some registries for models. And one last thing that we need to keep in mind when we are about to take this model and start using it is that the capabilities of the model and our use case are something that we can go for without doing some illegal or unethic stuff like let's give an example. You're trying to implement an LLM to help you speed up your hiring processes. So in that case, I think in some countries you're not allowed actually to use LLMs for several of these tasks. But even if you do, you need to keep in mind that the model has to be trained properly on unbiased data sets, and you need to look out for it.
Yeah, that's one thing about that. It's really worth understanding the context, right? Because it's you need to keep in mind that model can have capabilities, but it doesn't mean you cannot use it, right?
Right. Absolutely.
It's always context based. So a model can have biometric capabilities, and you may still be able to use it as long as you're not violating your legal laws, right? In case of European Union, this would be, for example, social scoring or manipulation, dark patterns AI, or facial recognition, right? What Ron mentioned, which is employment is one of the high risks, which means that at some point, some sort of a legal entity may ask you to prove that your system is not biased.
Right. All right, so let's talk about LLM licensing and compliance. AI licensing, who cares? This came from an AI model. How would I know? Good question. Maciek? Thoughts?
Yeah, that's a really complex topic, if I'm to be honest, Chris, because there are many licenses for LLMs. It's kind of funny when the hype on open source LLMs model started. The initial idea was to use the open source licensing model, which is already a huge mess, and we could have a different webinar about that. But this was the idea, right? People started publishing models under MIT or similar licenses, but then people noticed that okay, maybe it's not good enough. Maybe we need something more because there are edge cases and issues with already existing licenses. Maybe we need to have, I don't want to say better in general, but more suited licensing. And that's how some of the licenses specifically designed either for AI models AI pre-trained models or AI data sets were born. Then they're just people that are doing research and they don't want their models to be used for commercial reasons, right? They're happy providing their models. They're not always models suited to do business, but people are creative. So it's definitely a really complex space. Open source has a lot of meanings for people. The fact that something is public doesn't make it open source, right?
Mhm.
And even sometimes you can have stuff that is licensed under open source license, but it's hard to get. And on top of that, you get licenses conflicts. You get a lot of problems if you enroll a model with a license that, for example, would require you to publish your software or to publish your derived fine-tuned model, right? If you fine-tune it on your commercial data and suddenly the author knocks at your door and says, oh, now you need to go public, and then it isn't going public in the way you expected, then you're going to have a big problem, right? So you really need to understand the legal ramifications of the models you want to work with.
Hey,
And
Macho, can I throw one thing in real
Yeah.
quick on that? So, when you're starting a project and you're really sitting down and looking at the models, it's like development. You have some of your libraries dependencies that are very restrictive, where if you take the open source and do something with it, you have to share it. And that's the same thing that's happening here with the models. And that's what Maciek has been talking about, is the fact that some of these models, just be careful when you're starting out. Make sure you're looking at the licensing, because it could make or break you down the road. If you're taking your model, and Maciek, if I'm stealing any of your thunder, I'm sorry.
No, it's fine. Go for it, man.
But as you're working on your models and you're training it, just keep in mind that if it's a restrictive one that you have to potentially open up to the world, make sure that you're training it with data that's valuable for you, but also something that you would be willing to share with the world. Because Maciek said it, if the author comes knocking on your door and you're using their restrictive license that says you must share this, guess what? You must share it. Sorry, Maciek, back to you.
No, it's okay. Well, the only thing that is left is to mention that there's something called responsible AI license, or actually licenses, which is a group of licenses that are meant to clearly to provide a clear frame of reference of what can and cannot be done with a given model or data set. And if you encounter one of the models with a rail license, so first of all, read it, because there are a few variations of them, including ones marked only for research, and some allowing you to do commercial work. And then, but on the other hand, you can be quite sure that whatever is stated there is actually legally binding. They're quite well written. So they're like, an equivalent of officially supported open source licenses, right? You know what you're getting, and you just need to make sure you comply with the license requirements, right? Now, obviously, authors state not all of the dangers and risks are listed there, because it's hard to list all of them because of the human imagination. But yeah, I to be honest, I like the models that are released under the rail licenses, because it means that the authors actually thought about what should be the use cases for those LLMs.
Right. So let's talk about some of the insights from Hugging Face that we found. So Hugging Face supports over 68 known types of licenses, including other and unknown, which means there's actually more than 68 license types out there. The number of projects that we examined were 291, basically 292,000. And projects that had a license accounted for 42% of all the licensing. So you can see you have Apache as your big, your OpenRail, your MIT. And then as Maciek was mentioning, then they started getting a little bit more hey, we need to take a step back. We need to look at licensing types and models and make this something that's a little bit more in line with what we need, because we can't just use the same licensing types because we're doing something different. So that's why there's more licensing types out there now. So there's 68 plus, and it's again, the licensing is growing. It's one of those things where if you're looking at a license and you don't know how restrictive or not, consult your own lawyer, consult your own somebody, just to make sure that you're looking at licensing properly. So LLMs are like dependencies, and I've kind of talked about that a little bit with some of what I said. They usually have newer versions or improvements. Plan accordingly. An LLM can be upgraded or replaced by another LLM. So just like a dependency, when you're working with it, make sure that you actually implement it with the ability to upgrade it in the future. If you're not thinking about the potential upgrade path when you're actually working on, when you're actually, if you're not planning for an upgrade path, you're really kind of putting yourself in a quarter. So just make sure that when you're working with your LLMs, just like dependencies, put them off to the side, tie into them, but make sure that you're not being so intertwined with it that you can't upgrade. Because the last thing you want to do is get put into a corner where you'll never be able to upgrade that LLM, and you're going to miss out on any of the future or enhancements that are coming down the pipe. So let's talk about understanding and mitigating risks. So machine learning models are software components, so treat them as such. Again, like a dependency, make sure that you're treating it like software, put it off to the side. Make sure you're doing the basics. Don't just take a LLM model and just put it out into your production environment without testing it first. Make sure that you're doing a sandbox. Make sure that you're testing it out. Make sure that you're looking at your models appropriately and treat them with, could it be poisoned? Could I have taken something that was malicious? Because that is a potential. And so make sure that when you're looking at your libraries, make sure you're treating them like software. It's better to be safe than sorry. And take a look at the open source model, right? Fine tuning your CSP deployed model, your OpenAI. I mean, there's lots of instances that you have the potential of doing. So let me move to the next one here. So let's talk about understanding the risks.
Yeah. So first of all, I want to add to what you said that as some may probably noticed, we are talking about risk. We are not only talking about risk for open source models. So those risks are actually relevant even for closed models. So even if you're getting it from some endpoint provided by one of the other big companies that are providing very good and very big LLMs, you still may encounter those risks. So to name a few, we have issues when we can, when we run the LLM, we can someone with a malicious intent, or maybe it could be even someone that accidentally asked the right question or maybe the wrong question, and the LLM just spit out some sensitive or private data that it was either fine-tuned or trained or retrieved using the retrieval augmented generation approach. And we need to keep that in mind, that this can happen. And also we need to keep in mind that these LLMs are by nature probabilistic, and you will not get always the same answers for the same question. And in some cases, we may get inappropriate or incorrect responses, and we need to look out for that. And later on, we can say maybe how we can mitigate some of these risks. We can also have bias and discrimination. I think it's mainly depending on what is the training or fine-tuning data sets that you use, and malicious activity, of course. It could be during the the process of developing the model, or maybe even when it's deployed. And I think one very interesting risk that any model can have actually is model duplication, in which some attacker can create its own instance of your model just by asking it a few questions or interacting with it a little bit. And it will not be exactly the same model that you created, but it would be similar enough. And this would make it so some companies can lose their intellectual property if they are being attacked by such a model duplication, and it can let any attacker fine-tune their attack strategy or attack vector of your model. And I skipped. So hallucinations. This is something we came across quite a lot, and Chris, I think you also came across this.
I did. The problem that you run into with hallucinations is sometimes the model just doesn't come up with an answer, but it feels like it needs to still give you an answer. So it spits out gibberish, or it spits out some of what it has in its memory or what it kind of thinks. Sometimes this is related to a timeout or just something where the model just is corrupt or just has a problem. And so all of a sudden you might ask it something and it gives you something that's text. It may even make sense, but it's not right. And so that's something to, when you're dealing with models and hallucinations, make sure that you trust but verify on the data coming back. The other thing too, and Ron, if you don't mind, I'm going to touch on the duplication again. You also have hackers going out and typo squatting. And so making it so that if you mistype, you may get the wrong model. And so make sure that when you're keying in the model and you're keying in the information, you're putting in accurate in what you're looking for. Otherwise, you may pull somebody else's model inadvertently that you're, not the one you're after.
Right. So all these risks are, I guess, some of them are more theoretic or less visible in the wild, but I think that all of us hear every second day now of a new incident related to an LLM. And just to name two of them, so we recently had Inject GPT, which is some report that someone just asked politely an LLM agent, which is part of a LangChain framework. It asked it to print the content of the password file on the server that runs it, and it just printed it. So you can imagine what you can do with such interesting inputs to an LLM that you're running. And if you're running it on your own infrastructure, this is something that is it can really happen, and it's not something imaginary or theoretic. And and going back a little further, we had the very famous incident of Microsoft Tay.
Yeah.
Chris, you remember that?
Oh, absolutely. I lived it. I remember it. For 4 hours, Microsoft came out with their first AI. I want to say it was 2014 or 16. And when they did that, they asked the public, "Hey, we're launching our new AI. Ask it anything." And this model was called Tay, and what it was about was self-learning and self-growing based off of what users were asking it and the information that it was learning from people. And it was an experiment that was shut down after 4 hours because it was the first time that people, as far as AI and models go, learned about data poisoning. And it's where, data poisoning, if I feed it incorrect information and I tell the model that this is actually the right information, you can sway a model, or you can get a model to think that the stuff that you're giving it is actually the right information and the right stuff. So it was a short-lived experiment, but it was a great experiment because it taught us that, you can't just trust anything that comes in the doors. So with that, let's talk about mitigating risks. Maciek, what do you think?
Yeah, so I'm gonna be quick on this one because I think we talked enough about the legal side. But first of all, be mindful about your country's regulations. Keep in mind the context in which you're using a given model, right? Keep an eye on some of the public data sources about risks, not only vulnerabilities and not always vulnerabilities, but risks like Mitra Atlas and a couple other databases that you can Google. And this should allow you to like feel confident from the legal side, but there's also the technical side of things, right? And I think Ron, and Chris, you guys are better at this than I am. So
Yeah, so Chris, you can start and I'll complete the rest.
I'm sorry, what?
Yeah, you can start.
Oh, so knowing the model risks and weaknesses, make sure you're pulling from public sources. Make sure that you're using the right kind of scanner. Decide if the risks are acceptable for your application. Think about the guardrails. Think about what you can put in there that will help ensure that you're not going to open yourself up for something that you're not planning for. The guardrails are absolutely critical because it gives you the ability to say, hey, do not answer questions that are within a certain thing or a certain environment or within a certain scope. So it helps prevent the ability for some of the data poisoning. You can you can add in guardrails that says if someone's asking for a specific something, protect it. Make sure that it is not something that could accidentally put you in a bad spot. And so, the guardrails are absolutely critical to put in. In educating your developers and your stakeholders, right? Talk about model awareness and visibility and the ethics. I have a few friends outside of work that play with AIs, and they talk about how you could create a model that's very unethical. And so there's a lot of potential for abuse, and you just really need to just be fully aware of just what's out there and what you might be able to do.
Yeah.
Yeah.
So I just want to so I think that this is a great example of how the community and the opening up the models and the methods. This is a great example of how we can evolve by opening up to community, letting the community propose new tools and new suggestions. So for the guardrails and the scanners, we have a lot of good examples for open source projects that do that.
Okay. So with great power comes great responsibility. Uncle Ben. For those who know Spider-Man, you know the quote. So let's talk about security strategies for AI applications.
Yeah, so when we think of the security strategy, we think of, let's start with the security threat landscape. So I think that we mentioned it quite a few times, that we have any traditional software security threat. So we need to keep in mind that we are aware of them and not treating the whole LLM area as something that is not software security threatened. But there are more unique to LLMs security threats like data poisoning that I think it was really demonstrated well in Microsoft's Taze incident. And this is where the model is being fed up with some bad data intentionally to make it misbehave. Also, we can have other adversarial attacks and model manipulation that could be crafted by some attacker that wants to give some input that will make your LLM go crazy. Or I think that jailbreaking an LLM is one such good example. We've seen a lot of examples of jailbreak prompts that make ChatGPT and other very known services to just cooperate on any bad activity. And of course, we have the privacy breaches and the known insider threats where someone from the company that has gone rogue can do some bad stuff to your LLM. You probably won't even notice it because I think that one thing we didn't mention is that these LLMs, eventually the model is a bunch of weights. It's a lot of numbers, and it's not very easy to scan and see. So we need to keep in mind that even though we get a greater visibility due to community openness, we still have some black spots that we are not sure how to understand. So the general guidelines here, I think, would be to keep clarity and visibility, and we can start by just enumerating and knowing which models we are actually using in the company. And actually, it could be an easy task, but if you remember, we said that we can fine-tune models. So maybe you just downloaded the model and then you fine-tuned it, and then you kept only the fine-tuned model. So how would you track back the original model? And let's say that the original model, your foundation model, has some new vulnerability showing up. How will you be able to relay them? So actually, these are some of the tools that we are working on at Mend. And it's actually only part of the story because even if we know which models we're using, we need to be prepared to act when something bad happens. So we need to make sure that we're able to roll back or just disable our application that is using this LLM easily and quickly. And I think that the main thing about retrieval augmented generation, where your LLM could get access to some internal data, is to make sure that it doesn't have too many privileges and doesn't access anything. There are some solutions for that. And of course, keep in mind that security is an iterative process since we have new issues coming up, and we need to keep in mind to be updated.
All right, so let's talk about access models. So make sure that your models have only the access they need. Back to the example where we were talking about politely asking, hey, give me your password file. We need to make sure that, with the guardrails and with the things that we've put up, make sure that our models are only have limited access to what it needs. Because if you give it full access to, hey, here's everything, here's a whole database, now all of a sudden you could ask it politely and get all the fields and all the columns and all the information related to your database. So make sure that you put the appropriate controls up. Make sure that you give it the proper permissions. Read only for areas that should only be read only. Full write, read write, and update information for what makes sense. So models are like software. You got to make sure that you're planning accordingly, right? And maintaining the privilege system. If it doesn't need access or shouldn't have access, it shouldn't. And make sure that you test these out. It's not just, I hope that it's right. Put it in, put the guardrails up, put the proper controls around, and then validate those. Make sure that the validation works. Take data and anonymization. Take a look at it, and when you have data that's sensitive, make sure that the data, you remove who the person was or any characteristics of being able to look up the actual source. That way, by anonymizing the data, you don't know where it came from, but you do have the results and something that could be used later. Look at your development environment. You need to secure it down. Make sure that your development environment is not open where it could be compromised. We've seen this multiple times with open source. We've seen this many times with development software. A model you need to treat it the same way. Make sure that your development environment is clean you have it locked down. Make sure that you're following industry standards. Make sure you have antivirus and everything on there. So if your computer gets compromised, your model's not going to get compromised. Make sure that you're dealing with a good environment, dealing with libraries and frameworks that are current and not outdated, because you can have vulnerabilities there, which also adds the potential of vulnerabilities within your application. Finally, version and control. I mentioned it earlier. Make sure that you're versioning your models, so that way you can upgrade. And if you have a problem with it, make sure that you're doing versioning and your control, so you can say, oh, something bad happened, or the model became corrupted. Let's revert back to a previous model. So that way you have all the stuff you need to make sure that you're kind of working in a safe environment.
Yeah, and I think the last few points are more related to the runtime of the model, and we need to keep in mind to have some anomaly detection to either see if the model is misbehaving in terms of which outputs it is providing, and resource consumption. This is actually related to Marchek's kind of incident. So how much it costs and how the CPU is behaving, how much memory it's taking, and this could be an indication even for an attack, but maybe some human error. Also, we want to have some human in the loop in order to not make the LLM do some steps that are critical in some processes. I think I mentioned earlier the hiring decision processes, for example, and security awareness training. Just make sure that everyone around the development and usage of these AI tools are aware of the different risks and security vulnerabilities that are there, and are being up to date with everything that we already know.
Okay. With that, we have 3 minutes left, and we don't have time to read and get through the QAs because we are out of time, and the platform will kick us out here in a few minutes. I'll let James come back on here. What we're going to do is we're going to look at the Q&As. They'll give it to us. They'll give the who asked, and then that way we can respond with the answers to the Q&As. I'm sorry, guys, we ran out of time on it. But
great. Well, Chris, I want to thank yourself and Maciek and Ron. It was some really great material. I really enjoyed it, learned a lot. Thank you so much for sharing your expertise today.
Thank you. We appreciate being here.
Thank you.
Thank you.